So I'm Yash. As you already know, I'm the director of web, a BSc computing science student at the UFA in my third year with a business minor, and we'll be talking about version control today. So the first question is, what is a version control system? Now, since you're in a group setting and many people are working on the same files at once, um, instead of writing the same file again and just creating copies and having it in a folder and not knowing which one's the latest, which changes to pull from where, we use a version control system. So if you were using the old style, you need to create copies like on the slides, and then keep editing and then creating new copies and so forth, and that's going to be a pain, which you don't want to deal with. Which is where Git or other version control systems come in. We'll be focusing on Git in this workshop, and let's start with how Git works and how does it keep track of stuff. So Git uses something called trees. These are sort of data structure, and here you can keep track of what changes are going on where. Usually each repository that you have, which could be looked at as a folder, it has a main branch, and you could create commits. So each of the circles that you see here are called commits. Each commit has data allotted to that commit, so you could keep track of which is which. Usually these are called hash codes. And now let's say there are two people working on the same files, and you're over here, and then the second person wants to work on the same files. So what they can do is they can create something called as a branch, which is basically a copy of this commit over here that they have here, and they can start working on the branch independent from yours, and you could continue working on what you're working on right now. So once they've finished their changes and you have made changes as well, you can merge this branch back into main, and that's how all of the work that you have done together stays together. There's also something called as a head, which is how Git knows which commit you're on right now. By default, it stays on the latest commit, but you can move the head back and forth as you wish. And if you want to go back in each of these, like for example, if you're here and you want to go here, you could do something like this. The tilde stands for like behind, so you could go 1, 2, 3 commits behind. Each commit has a commit message with it, and it has a list of changes that have been made. So this could be additions in files, removal of files, and modifications in files. These are usually stored within Git itself. And now we'll be going into the workshop itself, and we'll be getting your hands dirty. So if people haven't worked with Git before, I'd highly recommend that you follow along with what I'm doing here. I'll be using a Google Doc, which is linked right over there. It's on nathacks.ca/Git workshop. So I'll give you guys a minute to go to the doc, and yeah. Is that clearly visible to everyone? Can someone give me a thumbs up? Okay. Alrighty. We'll be starting with the workshop itself now. We're going to be starting with something called, before we start, I'm going to make a difference. I'm going to highlight the difference between Git and GitHub. So Git is the version control system, and GitHub is the software that uses the version control system. So it's kind of like how you can have light bulbs. This is a bad example, but how you can have light bulbs and different companies can make the light bulbs, but the way a light bulb works remains the same, so it's kind of like that. There are other services that use Git as well. So you'll have to do 2 steps to set up. First would be to go on GitHub's website and create your account. So I'm already logged in, but once you go to github.com, you're going to see a different interface here since you're not logged in. So you can go and sign up over there. And once you're done with that, you can go to this link and install Git, the version control system, and install it. Since I have both of those things done, the next thing you'll have to do is go on your command line after you've installed Git and run these 2 commands. The email over here and the name should match your account details on GitHub. That's how GitHub knows that the commits were actually made by you. Yeah. Thirdly, you could use a software called GitHub Desktop. If you don't want to play around with the command line too much, you could use GitHub Desktop instead, and that's completely fine. The Git command line is powerful, but the GitHub Desktop works fine as well. You could again install that from here. And once you have done that, we're going to start by creating a repository. A repository can be looked at as a folder. So as you all are working on your projects, you're probably having all the code in one folder. So you could look at the repository as a folder. One repository usually is for a project. It could have multiple projects going on inside of it, or it could just have one. If you decide to have all the project files inside the one repository, it's usually called a monorepo. This could be when you're having, let's say, working on a website and it has a front end and a back end. And instead of having those as two separate repos, you could have it in the one same repo. And there are advantages and disadvantages to both. So it depends on your coding style. Though for this, for natHACKS, it's preferred that you use a monorepo because you'll just have one submission link for the GitHub repository. Once you've done all the setup, you can go to GitHub and on the top right corner over here, you could click on this and create a new repository. Since I've already done that, I'm going to show you a screenshot of what you're going to see. You'll be greeted with an interface that looks like this. For the purpose of this workshop, I'm going to be using a repository called mycoolrepo. But yeah, you could use anything. And for now, set your GitHub repositories access as public. We'll not be going into accessing private repositories for this workshop, and you wouldn't be needing it for natHACKS either. So set a name for your repository and set it as public. And then finally click on create repository. And then you'll be greeted with a very ugly looking page that says you don't have any files on your repository. You can ignore that for now. Then once the repository is there, this repository exists only online. It does not exist on your computer. It exists only on github.com. So now, if you want to work on this, you'll need a version of it on your computer, which you can do by cloning the repository. There are two things you could do. One is cloning and one is forking. So what happens when you click clone is it gets the repository from github.com, and then it creates a copy of it locally. So it's the exact same thing. And when you're doing forking, it's usually just you're copying someone else's repository to your account. It exists only on github.com. You'll again have to clone it to access it on your local computer again. To do a clone, you could use git clone my repo, but I'd recommend using GitHub Desktop because sometimes you'll hit problems with accessing the repository. So it's pretty straightforward to use GitHub Desktop. Yeah. If it's a private repository, however, you need to prove to GitHub that you're actually the owner of the repository or you have access. And to do that, you could use something called an access token. And again, that's out of the scope of this workshop, so I won't be teaching that. The repository should be public for the rest of the steps. So over here on terminal, I'm already inside the repository, but you could open it on terminal. And we are going to create a first commit. Since you're greeted with that ugly message that says there's no file on your repository, we can start by creating a readme.md, which is basically a readme markdown file. This is basically just a standard in Git when you're using version control. So when someone opens your repository, they can read the readme and they know what the project is about and how they can set it up. So once you're in your branch, once you're in your repository in terminal, you could just hit get status, and you can see that there's nothing in your nothing that's staged. And when you hit ls, you see there are no files inside this repository right now. But there'll be this file called .git, and this is what Git uses to track what's going on in the repository. So now, since I don't have anything, I'm going to create a blank file called readme.md. I'm going to use nano. And I'm just going to say hi. Now, once I run git status, you'll see there's this one untracked file. What this basically means is that Git wasn't tracking changes in this file until now. That's because the file did not exist until now, again. So you're going to tell Git to, OK, now I've created this file, and I want you to track whatever changes are going on in this file. You could do that by running git add. As an argument to tell Git what it needs to add, you could use the dot, which basically means add anything that's in this folder. But I'd recommend you use :/. This basically tells Git that, OK, you're going to go into my folder. From the start of the folder until everything inside, you're going to go and add everything. This could even be inside other folders that exist inside the repository. You just go inside every folder, add everything. If there are any more folders inside that, go inside that and add everything else as well. So we're going to be using this. It's more robust. But if you don't want to add all the folders, do not run this command. But for this workshop, we want to do that. So I'm going to run it. Now I'll run git status again. And you can see that there's a new file that's been created, and it's being tracked by GitHub, which is why it's in green. Now I'm going to create a commit. That can be done by running git commit and -m. -m stands for message. You need to have a message for each commit. Here I'm just going to write created readme.md. Make sure that all the messages that you put in each commit are very descriptive. This way, other people working on the same repository know what's going on. So now once I go to GitHub and I open my cool repository, which is over here, and you see there is nothing over here. There is no folder that exists, but you did create the file and you did commit. So what's happened here is that the file exists locally on your computer, but it does not exist on GitHub. And to let GitHub know that you have this file existing, you need to push these changes up to GitHub. You could do that by running git push. Since you're already on the main branch, that should work fine. But if you create a new branch, you'll need to publish the branch before you do that. Next, we already did git push. And to see which branch we are on, you could run git branch. This is going to list all the branches that exist in your repository, and it's going to highlight in green which branch you're currently on. And you could run git branch show current, and this will just show which branch you're on. Next, you want to pull. So now let's say you're working on changes. So let's say that I'm working on my branch, and now other team members have pushed changes to the main branch over here, and I want to get those changes locally. So what you could do in this case is run git pull. Since there's nothing over here, it says already up to date. But to test that it actually works, I'm going to create a new file online. I'm just going to call it test.txt. I hope no recruiter is seeing me make these changes. Doesn't look professional. But anyways, now I have test.txt online. But once I go to terminal and hit ls, I don't see anything that exists over here. This is because the file exists only on GitHub and not locally on my computer. So now I want to pull those changes down locally, which I can do by running git pull. Once I do that, it's going to give me a very descriptive message. All that matters here for now is that there's a test.txt with an extra line added. This tells you that one file is changed and one insertion has happened in it. And now once I run ls, you can see that I have readme.md and test.txt, which shows that I'm up to date. I can test that by running git pull again, and it's going to tell me that everything is up to date. Next, we are going to be talking about branches. So as you can see from this diagram, you need to have branches so that you can work on the same file simultaneously. You can do this through branches. And right now, I just have the main branch, and most likely once you create a repository, you're just going to be having the main branch on it as well. So I'm going to create a new branch called my branch. I can do this by running git branch my branch. Now once I run git branch again, I can see that there's a new branch called my branch that exists, but I'm still on the main branch as highlighted in green with the asterisk. Now I want to switch to my branch, and I can do that by running git switch, and in the name of my branch, which is my branch. Now once I run git branch again, you will see that now I'm on my branch, and it's highlighted in green and an asterisk, and that's how I know. When you're working on GitHub stuff and then you run into errors and then you go on Stack Overflow, you're going to see a lot of people use something called git checkout. And yeah, git checkout is the older version of doing all of these things, but I'd recommend that you do not do that because sometimes when you're having changes locally and then you have not committed those changes and then you git checkout to another branch, you're going to see those files exist even though those files don't actually exist, and that's going to confuse you a lot. So I'd recommend instead of using git checkout, use git branch to create a branch and use git switch to switch between branches. And usually this will give you an error when something is not committed and you're switching between branches. So now once I go on GitHub and I refresh, in the branches section, it just shows that there's a main branch, but locally there exists only there exists main and my branch. So what this means is that my branch exists locally on my computer, but GitHub does not know about it. So to let GitHub know that I have created a new branch, I'm going to run git push -u origin and then the name of my branch. So this basically tells you're going to push my branch to origin, and here origin means GitHub, which is online. So once you do this, it's going to push that branch online. And now once I go to GitHub again and hit refresh, I can see that my branch exists right now, and then you can switch to it and see all the files that exist in it. One thing that you should know while creating branches is, let's say I'm on this commit right now, and then I hit git branch to my branch. This branch is going to reflect whatever commit you were on in the branch you created that branch from. So if you were on the main branch on this commit and you hit git branch my branch, it's going to copy everything that existed on that branch at this point into the new branch. So that's something to keep in mind. The next is pull requests. So now you have two branches going on, as in this diagram, and someone else has worked on the main branch and you have worked on this code, and now you want to have this code show up in the main branch. And you could do that by doing something called a pull request, which basically is main requesting to pull code from your branch. And you could do that by pull request. So to do that, I'm going to create a change on my branch. I'm going to create a new file. I'm going to call this my change. XD. And saved. So the file exists. Now I have to add the file again, so Git knows that it has to track my change.txt, which it has done now. I can run git status again to see if it has done, and it has indeed. Now I'm going to commit this with a message saying created my change. Now this commit exists locally. I'm going to push it online by doing git push. Since I've already published this branch, Git knows which branch to push it to, and that's done. So now once I go to my branch on GitHub, you can see that the file exists. And because GitHub is smart, it's going to prompt you to say, okay, there's this new branch that has changes, and you might want to you might want to create a pull request and pull those changes into main. So I'm going to do that right now. When you're doing this, you can scroll down and see which all commits are being pulled from the other branch, and you could see them in terms of the files itself. And here you need to create a title for your pull request. That could be a one-liner describing what you did. But in the description section over here, it's best that you you describe in detail what you have changed. And this is really helpful when people are pulling from your branch and they know what's going on. So they're not getting themselves into something they didn't sign up for. So have this as descriptive as possible. You could have bullet points. I'm just going to say created a text file called my change. Also, this is formatted in Markdown. So you could just use the funky syntax for Markdown, and it'll show up like this. But anyway, that was a side note. Other things to keep in mind are, while doing a pull request, it's best to have a reviewer go through your code before you pull it. You could do so by clicking on reviewers and just adding the username of the person. Also, optionally, you could assign this task to yourself. This could be useful if you're using projects or just tracking what tasks have been given to everyone else. So in that case, you could just assign a ticket to yourself. That'll be something nice to do. Next, you could hit create pull request. And now, since I'm the only one in this repository, I can merge it on my own. Optionally, you could add a rule that says that each pull request needs to be reviewed by one person before it can be merged. And since you're in a hackathon, you might not need to do it. It could just cost more time. But then it's the best thing to do, because sometimes there'll be conflicts and you need to know how to merge, how to deal with those. Or maybe some changes that you think a line does something, but it actually ends up doing something else. So in that case, it's best to have someone review your code. I'm going to ignore that for now and just confirm my pull request. Now you can see that my pull request has been successfully merged and closed. So if I go back to my cool repo in the main branch, which it is in, you can see that my change.txt exists in the main branch, which means our pull request was successful. But then there's something that you need to keep in mind while doing pull requests, and those are conflicts. Oh, also before we go to conflict resolution, uh, people usually do merges, but then there's something called a rebase, and this is just two different ways of doing the same thing, sort of. So what happens in a rebase is when you're doing a merge, you're having a separate branch, and then you're pulling this over here. So you're going to create a new commit over here, which is basically a combination of these two once they're merged. But then some organizations do not like to have this. They just want to have a uniform linear history. So they just want everything to be in one line. In this case, you could use something called rebase, which basically, when you rebase, what it's going to do is it's going to take all the commits from your branch and copy all of those commits onto the main branch. So then in that case, you're just going to have a linear history in on Git. And now let's come to conflicts. During this hackathon, you're going to run into conflicts every time you run a pull request, because you're just doing everything last minute, and then people are going to be writing on the same line as you. And in that case, you need to know how to resolve conflicts. So to mimic what happens in a conflict, I'm just going to be on main branch here, run git pull, and get status. Yep, so there's nothing that's unstaged. So I'm on main branch, on my branch, and on GitHub, I'm going to my branch as well. I'm going to close this tab. Ooh. Yep, hitting refresh, and now we are on my cool repo, on my branch. Also, the one commit behind that you see here, that's basically the merge commit, which in this case, the commit just has information that it has information from the main branch as well as merge changes from my branch. We're going to ignore that for now. Actually, I'll just create a new branch. It'll be easier to understand what's going on. Git switch main, git pull. Now I'm going to create a new branch called I like conflicts. Oops. Now I'm going to publish this branch by running git push -u origin and I like conflicts. Okay, git status, and we're up to date. And on GitHub, I should be able to see I like conflicts now, which I do. All right, so then this is now a copy of the main branch because I created this branch from main. I'm going to create a new file here called nano my conflict.txt. So now we have a new file, and I'm going to add it, and then I'm going to commit it. Yeah, I hope no employee is going to see these commit messages. So now we're on I like conflicts, and we're going to fight. So what's going to happen right now is I'm going to create a change locally on my computer, and I'm going to edit that same line online. So I'm going to go to my conflict.txt online, and I'm going to edit it to I'm an angry person, I guess. All right. So now this change exists only online and not on this. I can run git status. Oh, interesting. Anyways, I'm going to go to my conflict.txt. And since I have only one line, it's going to be an easy way to make a conflict. So I'm just going to write something else here. So now I have this file. I'm going to add it again. Then I'm going to commit. Oh, I just realized I made an oopsie. So I'm going to go to the main branch and make the change over there, actually. You know what, I'm going to start over again. All right, so we are on the same level as I like conflicts. And I can get pushed just to check. And everything's up to date. So now what I meant to do was go on main, where it already, okay, it does not. I'm going to do is, yep. I'm going to go to my change.txt and create the conflict here instead. So instead of my cool change, I'm going to say my excellent change. Because why not? Now I'm going to go to the same file as that, which is my change. I know my change. Oops. I did not mean to do that. Also, don't follow the messages I'm making. These are very bad messages for commits. Okay, so we have changed the same file on main and also on I like conflicts. So when I create the pull request over here, Git is going to reach into a confusion, which it has already. But I'm going to walk you through what the conflict is. I'm going to create the pull request. So now what has happened is on the main branch, there's a file called mychange.txt, which has just one line. And then on I like conflicts, there is the same file with the same one line. On main, I've created one change, and then on I like conflicts, I've created another change in the same line. So both the files have that one line with different versions, and Git does not know what to do. In this case, we need to tell Git what to do. As I've done this in the doc, you could run git status here. I'm going to run git pull first. Git status. I don't know why that happened, but on GitHub, you can see that there's a conflict over here. And to solve that conflict, you can just click on resolve conflict. And then you're going to get greeted with this very ugly looking thing. What this means is that there's this one line that exists in both files on the both branches. This is I like conflicts, which is our branch or the branch we're currently on. And this is going to be sending it, and it's going to be received on main. And this is the line on I like conflicts, and this is the one on main. So we need to decide what to do here. To make that decision, let's say I don't want to use either of them. If you wanted to use either of them, just get rid of everything else except that line. So if I wanted to just have this, I would get rid of this and then this line, and we should be good to go. But in this case, and as you will probably have to deal with during the hackathon, you might have to use not only your changes, but also the version that the other person has used. So to do that, I'm going to take out from this one, but I'm also going to keep excellent from here. So I'm going to get rid of all of this and this. So now I have this one version, which is a mixture of both the lines that I have. So I'm going to mark that as resolved. I'm not used to having GitHub zoomed in so much. And then on top, you'll see this thing called commit merge. This basically is a merge where the conflict has been resolved. Now you should see a check mark here that says you're good to merge and there are no conflicts, which we do here. Now I'm going to hit merge pull request and confirm. So now once I go on main, you'll see this version on my conflict, my change.txt, which is a combination of both the changes we made. Now if I run, if I go to git main, if I go to the main branch and I run git pull, I have all the changes over here. And yep, with that, we have come to the end of our workshop. So before you go, I just want to tell you that now, with all the things you have learned through this workshop, you should be good to deal with all Git issues that you'll deal with in this hackathon as well as in the future. And even though there are more concepts that you need to know, this is basically everything you need to get started and get shit done. Uh, Please cut that word from the live stream. um, Also, I want to leave you with something cool to look into. So if you go into comments over here, you will see that some of these are verified and some of them are unverified. And normally you will not see any of these on your GitHub account. So what I've done is there's something where you need to verify your commit, which I've enabled on my account. And because GPG just did not want to work, so I disabled it, which causes these to be unverified. But if you want your commits to be verified, you could do something using SSH or GPG keys. So that basically tells Git, okay, that gives Git a way to verify that you're actually the person who is creating the commit. And why you need to know this is because if you remember during setup, you just go to the command line and enter your name and your email, and you don't really give Git proof that this is actually your account. The account that belongs to this email is actually your account. So to verify that, you can use SSH or GPG keys, and I'm not going to talk about that. You could figure it out, but it's pretty cool to have these verified tags next to your commit. And with that, if I don't have any other slides left, yep. Before I go, these are some resources that you might like to have. The first is the doc that I've used for this workshop, which is on nathacks.ca/Git workshop. The next is interactive tools to learn Git. I've used this website called learngitbranching.js, and it's a really beautiful way to learn Git. It's like a video game, but with learning Git. So that was pretty fun to do. There's also a Git cheat sheet that's linked onto the slides. Um, if you need access to the slides, they're on the Luma link for our workshop, which was originally scheduled for, I think, the 5th or something, which did not go live. So I'm doing this again. So you could go and get these links from there. And yep, that's everything. If you have any issues with Git, just feel free to come up to me and ask me questions. I can help you resolve them with you. And yeah, thank you.